Hi everyone, welcome back to my channel Vertex Manoj Roy. Exercise 9.1, the function to find the range of the quadratic equation. This is most important part, like the most important part in functions to find the range. Like this is not easy actually. I have taken the first example from question number 10, and question number 10 is not a quadratic function, it's a linear function. You can see mx plus c condition. This is linear form, like it's a straight line equation. So first in question number 10, I'm going to explain like how we can find the range in a straight line. And then I'm moving to quadratic functions so that we can have the difference between these two types of questions. In first part, like there is no problem to find the range in linear function. Just very simple. It's very simple. What? When the domain is given, for example, like given find the range is from 1 to find the range when the domain is 1, 2, 3. So it's very simple. You have to put the first domain like 1, 1, and is coming 4. And when you substitute 3, so is coming 14. So your range like of this part is very simple. You have to use the same thing for f of x and 14. Remember when you write the range is always with fx and domain is always with x is given. Like we have done the first part. In second part, when the range, like, we need to find domain now, and the range is given here. So is what we have to do in the equation, in the given equation, like this is like fx is minus 1, so is coming 5x is equal to 0 and x is coming 0. From the 1 is coming 0, and from when we substitute like 5. So it's coming 5x is equals to 6 and x is coming 6 upon 5. So you can write, sorry, the range, domain you can write the same sign. There is no problem from 0 to 6 upon 5 and you can check the answer. We can check the answer of the first part is 4 to 14 and 0 to 6 upon 5. 4 to 14 and 0 to 6 upon 5, we have done it. There is like no problem to find the range in the linear function. Like there is no like this one method: minimum value, minimum domain, minimum range, maximum domain, maximum range. There is no problem. The problem is with the quadratic function. Let me do like one more example, like part D. In part D, we have to use the same like x is 1. So I write fx is equals to 7 minus 2x. When I substitute 1 is coming 7 minus 2 is 5, and when we substitute like 3 is coming 1. So 5 and 1. Okay, this is very simple. You can write, or like what is the minimum number? You can write the 1. We can check the answer of this part is coming from uh, part 1 to 5. So it's like normally we write from 1 to small to big number. Small to big number. This is fx. This just we have to careful like here. This we have to write a small number and the maximum number. This is okay. And when we move to part like this is the first part D, and second part is so when we write a small is very like a small number because this is an x or fx and then large number. So second part when we write minus 1 is equals to 7 minus 2x. I'm finding the domain now. So it's coming 2, x is equals to 8 and x is coming 4. And second part, when you write like 5 is equals to, because we have to use the same thing here, 5 equals to 7 minus 2x. 2x is equals to 7, like this will become minus. So it's 2, and x is equals to 1. So the domain is now minimum value is 1 and 4. So 1 and 4, and we have done it. We can check the answer of this part D. 2 to 4? No, it's 1 to 4 is right. So now I'm moving to question number 2, which is completely quadratic form. Now, most important in like in function, and we have like many like students do many mistake in examination. Okay, what's the first step in quadratic function to find the range? Domain is given from here, and equation is given here. Okay, the first step is okay. You can find the two values from the minimum domain and maximum domain. This is the first step. Step number one. Step one, what we're doing, use domain, use domain, and find fx. Okay, the first fx is coming from minus 2 is minus 2 square, and minus 2 is here. 4 plus 4 is 8. Okay, 8 is coming. And second, so it means the coordinates are, this is, so the coordinates are, we can write, the coordinates are minus 2 comma 8 because this is x and this is the value of y. Okay. Second, I'm writing 0 because the 0 is given in there, like here, this 0 and minus 2, domain is given. When I substitute 0 here, the value is coming 0 square, minus 2 and 0. Sorry, and this is also coming 0. The coordinates are coming 0 comma 0. Okay, what is the next step? Step number, we cannot write like the range is coming from 0 to 8. Sometimes it becomes like it becomes right, but it is not always. So step number 2. Step number 2 is that you should find the turning point. Find the turning point, stationary point, minimum point, maximum point. And because it's a positive x square, when you are happy, you will be positive. So positive means this is the shape of the positive, happy face. Yeah, because when you are positive x square, you will be happy. The shape is there. We have a minimum point, turning point is there. Okay, turning point. What we do in the turning point, we need to have the equation y equals to a x minus h whole square and plus k. I would like to explain like methods here how to find the turning point is also called a stationary point. X squared minus 2x. The first step is what we can use a complete square form is x minus 1 half is 1 square minus 1 square. And for this you have to like watch my video of chapter number 4 how we can find convert into turning point form. So turning point is coming 1 and minus 1. Okay, I would like to explain the other way to find the turning point because this is y equals to x squared minus 2x. And okay, dy upon dx, we can use it because we are not like we are doing advanced, all chapters are coming in the exam. So when you differentiate is coming 2x minus 2. And remember when you find the turning point, this is called the minimum point, and differentiation, the gradient is always 0. So 0 equals to 2x minus 2. X is coming 2 upon 2 is 1. Okay, x is 1. Then I put this value in the equation here. So what is y? So y is coming 1 minus 2 is minus 1. So let check. Still is coming. The turning point is coming 1 and minus 1. So you can like we have so many ways to find the turning point. It's up to you to which method you want to use. This is like this is the turning point, and this is also the turning point. Okay, we have done the turning point and this turning point. There is one more method to find the turning point, but this video will become very lengthy, I think so. Okay, and now what I'm writing all these coordinates minus 2, 8. I want to use different color now. Okay. The first point is minus 2, 8. The second point is 0, 0. I will write all the coordinates. Okay. The third, this turning point is also involved. Okay. My question is how we can find the range of this quadratic function. I can also draw the sketch to find the turning point, but maybe I will try my best to explain. In this, what is the value of y? Minimum value of y is here, like here the y is 8, here y is 0, here y is minus 1. Okay, do I have to use the turning point or not? This is my question. The turning point, do we need to use or not? If your given domain, check your given domain. Just check it out. This given domain of x, this from minus 2, minus 1 and 0. This x, the turning point of x, does it lie in this domain? Yes or no? Check it out. Minus 2, minus 1, 0. This one is not coming in this given domain. Given domain is very important. When it's not coming, so I will not use the turning point. I will not use the turning point. I will use only 0 and 8. So your right answer to find the range of this question is 0 to 8. Okay. If I illustrate with this, like with an example of like a sketch, I would like to draw because we have to understand how this is okay. Like in this question, we do not need the turning point. Why we do not need the turning point? I have given the reason because the given domain, in the given domain, the turning point x is not lying. When you draw the sketch of this part, to draw the sketch, we need a turning point. Okay. So the turning point is like 1 and minus 1, 1 and minus 1. I can write here 1. So turning point. And on the turning point, if you see my video like question, like chapter number 4, we always draw a line of symmetry at a turning point. And the one coordinate is 0, 0. This is here 0, 0. And second is minus 2 and 8. Minus 2 and 8 means we can write minus 2 and 8 is I have to change this part. This is minus 1. This coordinate first, I will use the green color, I think so. This is the turning point. This is second coordinate. The third coordinate is coming, 8 is here, suppose 8 is here. So 8 will be, we do not need to make the exact sketch, please. So now sketch is coming like this and it will move like this. But when you see the question, the given domain is minus 2 to 0. Okay, minus 2 to 0 means I have to be careful. Minus 2 to 0. This is my target. Okay, so it means my area of the given sketch is from here to here only. So it means I do not need the other part of the graph. I do not need. So it means check. This is the graph of this given question. Like when the domain is minus 2 to 0. I have to I had to explain with the turning point. The turning point is not coming in the given domain. So I will not use the turning point and this is the right answer. Please make this method. We do not need to draw the sketch, but like what we can see, the turning points domain when the turning point x is coming in the given domain, I have to use turning point. Otherwise, don't use turning point. Please always find the turning point. Question number 12, fx. Let's see if you like here. Find the domain. Okay, the range is given here. Okay, let's see. when we write 1 is equals to 4x squared minus 3, 4, 1, and x is coming plus minus 1. Okay, and when we write 13 is equals to 4x squared minus 3, and 4x squared is equals to is 16, and x squared is equals to 4, and x is equals to plus minus 2. Okay, now we need to find the domain, and the range is given here. And when you see the equation in the form like here, so the turning point is from, you can write domain. So the domain normally, like if you see, we can have from the 1 to, because there is no equal to sign here, so 1 till 2, or we can write from minus 2 to minus 1, but I think so in the book normally always positive domain is given. So this B part is most important. We can write like 3-star question, or we can write 5-star question. Okay, my target is the same. That's how we can find the range, x plus 1 whole square. First thing, when I check the first part, the domain, I just step number 1 is what? I just put all the values of the domain. I will put 0 is coming, 0 plus 1 whole square is coming 1. The first coordinate is 0 comma 1, and when I put here the value 2 is coming 2 plus 1 whole square and is coming 9, and the second coordinate is 2 comma 9. Okay, and what we need, I told you we need the turning point. Okay, the turning point of this question, I'm writing here the turning point. The turning point of this question, the plus 0 is there. The turning point of this question is minus 1 comma 0. Okay, the turning point we have got it. Okay, now step number 1 for the second part, I'm doing two questions like together, both the questions. I have to put here first minus 2. When I substitute minus 2 in the equation, the minus 2 plus 1 whole square is equals to 1 square is 1. So the coordinates are minus 2 comma 1. In the second point, I have to put 2 here, and the 2 is coming 2 plus 1 whole square is coming 9, and the coordinates are 2 comma 9. Okay, now target, how to find the range now. If you want to find the range, I told you one thing, this we always check the turning point. This turning point, you check first the value of x, the turning point. The value of x is what? Minus 1. Okay, and here, what you have to check for this part, here y is 1, here y is 9, and the turning point y is 0. I'm doing this part first. Okay, let's see. 1, 9, and 0. But one thing, the turning point x, this x, check this in the given domain 0 to 2. 0 to 2. This turning point, which is x equals to minus 1, this minus 1, does minus 1 lie in this given domain, part 1? Yes or no? Check it out, minus 1 is not here. So, do not use the turning point. So, I will not use this. So, right answer will be, I will use the value from 1 till 9. So, small value is 1 and fx is 9. But when you move to this part, the value of y is here 1, the value of y is here 9, and the value of the y in the turning point is 0. But check, the turning point x, which is minus 1, does it lie in the given domain minus 2? to 2. Does it lie? Yes or no? If minus 1 is coming, yes, then I have to use turning point. I have to use all three coordinates. Now, in this all three coordinates, what is the minimum value of y? Because turning point is involved now. What is the minimum value? 0, 9 or 1? The minimum value is 0 and maximum value is 9, 1 is 9. So now we have different answer because of the turning point and because of not the turning point like here. So whenever you find like the range in the quadratic equation, you can find the domain first, all the domain, and also find the turning point even you need or not. Always find the turning point. After finding the turning point, just check the turning points x. Does it lie in the given domain or not? If the turning points x is lying in the given domain, use the turning point to find the range. If the turning points x is not lying in the given domain, do not use turning point to find the range. This is the most important part of the function. If you think this video is useful, please share with your friends and like my video and subscribe my channel. Once again, it's a normal thing. And I would like to say, have a nice day.